Yesterday we saw regarding tangents, that is how are the tangents drawn when a point is there on the circle and when a point is outside the circle, and how many tangents can be drawn. So we saw that when the point is on the circle, we can draw only one tangent. When the point is outside the circle, we can draw two tangents. And when the point is inside the circle, no tangent can be drawn. That we saw yesterday. Today we are going to get some information regarding congruent circles and concentric circles. You can see that two circles I have drawn. So what is congruent circle means? If I cut this circle and place it on the other circle, or that is the periphery or the boundary of the circle coincides with each other. That means the radius of the circle is same. So what are congruent circles? Circles in which centers are different but the radius is same. Such circles are called as congruent circles. So what are congruent circles? Two circles having same radii. Two circles having same radii but different centers are called congruent circles. So came to know what are congruent circles means? Two circles. So how many circles are taken? Two circles are taken. You can see I have taken. This is circle C1 and this is circle C2. Both the circles are having the same radii, but the centers are different. Such two circles, we call them as congruent circles. So two circles having same radii but different centers are called congruent circles. Now we will go to the next concentric circles. You can see the diagram. Can you see the diagram? C1 and C2. C1 is a smaller circle and C2 is a bigger circle. C1 is inside the circle C2. So you can see the radius. The radius of the circle C1 is less and the radius of the circle C2 is more. That means what is happening? The center you can see. For C1 circle also center is O and for C2 circle also center is O. So what is happening? The centers are same but the radii is different. The opposite of this. Here the radii is same and centers are different. Here the center is same and the radii are different. You can see C1 circle is a smaller circle, so its radius is less. C2 circle is a bigger circle, its radius is more. So we can say that two circles having same center, very important, but different radii are called concentric circle. One more very important thing is over here. Concentric. Con means same. Centric means center. So the circles having same center. The word itself can make you to understand what is meant by concentric circles. So came to know what is meant by concentric circles? Two circles having same center but different radii are called concentric circle. So you came to know two types of circles, congruent circles and concentric circles. When you compare these two circles, what can you say? In congruent circles, what is happening? The centers are different and the radii is same. In concentric circles, centers are same and radii is different. That is what the difference between congruent circles and concentric circles. Now we see theorem 4.2. This theorem is based on that is an external point is there. From that external point, two tangents are drawn. We have to prove that the two tangents drawn are equal. So the tangents drawn from external point to a circle are equal. So what does the statement says? The tangents drawn from external point to a circle are equal. So this is the statement. So what does the statement says? The tangents drawn from external point to a circle are equal. So we have to draw the diagram. So O is the center of the circle. PQ and PR are the tangents drawn to circle at Q and R respectively. So that is what given over here. So you can see P is the external point. PQ and PR are joined to the circle at Q and R. So point of contact for PQ is Q and for PR is R. And O is the center of the circle. So we will write it down. What is given? So what is given? O is the center of the circle. PQ and PR are the tangents drawn to circle at Q and R respectively. So came to know. So what it is? O is the center of the circle. PQ and PR are the tangents drawn to circle at Q and R respectively. So what we have to prove? To prove what it says? The tangents. Okay, so which are the tangents? PQ and PR. They are equal. So you have to prove PQ is equal to PR. The tangents drawn from external point to a circle are equal. So you have to prove PQ is equal to PR. You cannot prove it in this way. You have to do construction. So what is the construction you have to do? Let us see. Construction we are going to do is that we are going to join OQ, OR and OP. OQ and OR, and then we are also going to join OP. We have to join OQ, OR and OP, which is the construction, because without that we won't be able to prove PQ is equal to PR. So what is the construction we are going to write? Join OQ, OR and OP. That is the construction. So what is the construction? Join OP, OQ and OR. This is a construction. So came to know. So we are going to join OP, OQ and OR. Now we have to prove that. What we have to prove? That PQ is equal to PR. Okay. Now we know that OQ is the radius and PQ is the tangent. The previous theorem 4.1, what does it say? That the radius and the tangent are perpendicular. The radius is perpendicular to the tangent. So this angle is 90 degrees. Similarly, OR is also a radius and PR is also a tangent. So this angle is also 90 degrees. Okay. Then, if this is 90 degree, means OQP and ORP are right angled triangles. So, the hypotenuse for triangle OQP is OP and the hypotenuse for triangle ORP is also OP. Then, OQ and OR are equal because they are radii of the same circle. So, we are going to prove triangle OQP and triangle ORP are congruent by using the postulates of congruency. Right angle, hypotenuse and side. That postulate we are going to use. Right angle, angle OQP and angle ORP is equal to 90 degree because radius and tangent are perpendicular. Then hypotenuse, OP is equal to OP, which is the hypotenuse, and it is a common side. Then another side, OQ and OR is equal because they are area of the same circle. So we can prove that triangle OQP congruent to triangle ORP. If the triangles become congruent, means what happened? The other side, that is CPCT, common parts of congruent triangles, that means PQ will become equal to PR. Then angle QPO will become equal to angle RPO. And angle QOP will become equal to angle ROP. That is the common parts of congruent triangles. So that is how we can prove that PQ is equal to PR. So what we are going to take? We are going to take Rhs postulate. We are going to prove these two triangles are congruent by taking Rhs postulate for congruency. So let us see what is the proof. So what does the proof says? In triangle, what does the proof says? That in triangle OQP and triangle ORP. So in triangle OQP and triangle ORP, angle OQP is equal to angle ORP is equal to 90 degree. What is the reason? Radius and tangent are perpendicular. This is your theorem number 4.1. So radius and tangent are perpendicular. Then OP is equal to OP. Why? Because we know common sides are always equal, which is the hypotenuse. Then OQ is equal to OR. Why? The reason, radii of same circle. I told you, in a circle all the radius are equal. Therefore, triangle OPQ congruent to triangle OPR. Therefore, what we have to prove? PQ is equal to PR, which is nothing but CPCT. CPCT means common parts of congruent triangles. So we wanted to prove PQ is equal to PR. So we have proved PQ is equal to PR. So once again, I will show you the proof. So now we came to know that the tangents drawn from external point to a circle are equal. So what is the circle? O, this circle you have drawn with O as the center. Which is the tangents? PQ and PR are the tangents. And how they are? They are touching the circle, that is at Q and R, PQ and PR are the tangents. What you have to prove? PQ is equal to PR. Construction. What construction we have to do? We have to join OQ, we have to join OR, and we have to join OP. We are going to prove with the help of a congruency postulate, that is Rhs postulate. That is right angle, hypotenuse and side. So in triangle OQP and triangle ORP, angle OQP is equal to angle ORP is equal to 90 degrees because radius and tangent are perpendicular. OP is equal to OP, which is the hypotenuse, which is the common side. OQ is equal to OR. Why? Because they are radii of the same circle. Therefore, triangle OPQ is congruent to triangle OPR. Therefore, PQ is equal to PR. Why? Because they are the common parts of the congruent triangles. This is proof 1. I have erased proof 1 so that I can show you proof 2. Same statement, same diagram, given is same, to prove is same, and construction is same. Here proof 2, what we are going to do is, we are going to use Pythagoras Theorem. So using Pythagoras Theorem also we can prove that the tangents drawn from an external point are also equal. So which theorem we are going to use? Pythagoras Theorem. So let us take first, because to use Pythagoras Theorem I told you and one angle should be right angle triangle. Now we know that OQP is right angle triangle because angle OQP is equal to 90 degree. So in triangle OQP, angle OQP is 90 degree. Therefore, we can use now the Pythagoras theorem. If this is 90 degree, which is the hypotenuse? OP is the hypotenuse. So what you can get? OP square is equal to OQ square plus PQ square. Take this as equation number 1. Now let us go to second triangle. Which triangle? In triangle ORP. So in triangle ORP, angle ORP is equal to 90 degree. So which became hypotenuse? OP became the hypotenuse. So therefore OP square is equal to PR square plus OR square. This is your equation number 2. See equation number 1 and equation number 2. So from 1 and 2, using axiom 1, things which are equal to same thing are equal to one another. So what we can write it down? From equation 1 and equation 2, OQ square plus PQ square is equal to PR square plus OR square. Okay. See OQ and OR. What are OQ and OR? OQ and OR are the radius of the same circle. So both will be equal. So what happens? Both will get cancelled. So what is remaining? PQ square is equal to PR square. The reason OQ and OR are the radii of same circle. So same things get cancelled. Now PQ square is equal to PR square. Therefore PQ will be equal to PR. So that is what we wanted to prove. PQ is equal to PR. So this is proof number 2. The statement, the diagram, the given, and to prove and construction is same. So what does the proof 2 says? We are going to take or we are going to apply Pythagoras theorem. So in triangle OQP, angle OQP is equal to 90 degree. So this is the hypotenuse. So OP square is equal to OQ square plus PQ square. Again in triangle ORP, what will happens angle ORP is 90 degree. Therefore OP square is equal to OR square plus PR square. Using axiom 1, from 1 and 2, what we can say? Things which are equal to same thing are equal to one another. So OQ square plus PQ square is equal to PR square plus OR square. OQ and OR are the radii of the same circle. So same things which if they are present in equal sign on both the sides, it gets cancelled. So we got PQ square is equal to PR square because OQ and OR are the radii of the same circle. Thus PQ square means square root of PQ square is PQ, square root of PR square is P. So PQ is equal to PR. So theorem 4.2 gives some important notes. What are the important notes? Let us see through this diagram. We proved that PQ is equal to PR. We proved by taking Rhs postulate and we proved by taking Pythagoras theorem. In Rhs postulate, what we proved? Triangle OQP is what it is? It is congruent to triangle ORP. So you proved triangle OQP congruent to triangle ORP. So if the triangles become congruent, means whichever the remaining angles are there and whichever the remaining sides are there, they become equal. They are called as common parts of the congruent triangles. So which are they that? Now we show that PQ is equal to PR. Then OQ is equal to OR we have already taken and OP is equal to OP is a common side proved. Then angle OQP is equal to angle ORP is equal to 90 degree we have already taken to prove it at Rhs postulate. So now which angles are left out? angle QPO and angle RPO. So angle QPO is equal to angle angle RPO. One more angle is there. Angle QOP is equal to angle ROP. Angle QOP is equal to angle ROP. Why? Because CPCT. Okay, common parts of the congruent triangles. So we can prove that. That means what? OP, whatever the line you have drawn, it is an angle bisector of angle P and angle O. That is what these two statements prove that. What does it prove that? OP. So therefore, OP is the angle bisector. What is meant by angle bisector? Means a line which divides the angle into two equal parts. That line is called as angle bisector. So OP is angle bisector of angle P and angle O. We can prove from this. This is very important because while we are calculating the sums, we will be using this. So OP is angle bisector of angle P and angle O. Now pay attention over here. Now OQPR is a quadrilateral. Now angle OQP and angle ORP is 90 degree because radius and tangent. So these two are 90 degree. In 8th and 9th standard you studied that sum of the angles in a quadrilateral is how much? 360 degree. Okay. Now these two, this is 90, this is 90. So sum of these two angles will become 180 degree. So now what will be these two angles? That is very important for us. Now if these two becomes 90 plus 90 is 180. So from 360 if you subtract 180, so these two angles should also become, sum of these two angles should also become how much? 180 degree. Means angle Q plus angle R is 180 degree. Means angle O plus angle P is also 180 degree. We can prove this. This is also we are going to use for calculating the sum. So what we got it as? Angle Q plus angle R is equal to 180 degree. Why we are able to prove? Because angle Q is 90 degree, OQ is the radius and PQ is the tangent. Angle R is also 90 degree, OR is the radius and PR is the tangent. So angle Q plus angle R is equal to 180. Sum of all the four angles is 360. So naturally angle O plus angle P. So angle O plus angle P will be also 180 degree. So if angle O is given, we can find out angle P. If angle P is given, we can find out angle O. For example, this is very important for calculating the sum. For example, angle O is given 120 degree. Find angle P in this. So we can use this. Angle O plus angle P is equal to 180 degree. So angle O value is 120. So angle P will be 180 minus 120. So what we will get? Angle O plus angle P is equal to 180 degree. 120 degree plus angle P is equal to 180 degree. Therefore, angle P is equal to 180 minus 120. So angle P is equal to 60 degree. Similarly, if angle P is given, take angle P is equal to whatever the value of angle O is given, subtract from 180, you will get angle P. For example, angle O is given to you. Now let us take that angle P is equal to 80 degrees given. How will you find out what is angle O? So what will happen? Angle O plus 80 degrees is equal to 180. So what you have? Angle O plus angle P is equal to 180 degree. Angle O plus 80 degrees is equal to 180 degree. Therefore, angle O is equal to 180 degree minus 80 degree is equal to 100 degree. So this, whatever the statement we got, will help you to find out angle P when angle O is given and angle O when angle P is given. In this, one more sum can be asked. That is, if angle QPR, that is angle P, is, let us take it is 80 degree. So what will be angle QPO and what will be angle RPO? Just now only I told you, OP is the angle bisector, which it divides the angle into equal parts. So angle QPO and angle RPO will become how much? Half of angle P. What is angle P given? 80. Half of angle P is how much? 80 by 2, it will become 40. If angle QOR is 100 degree, how much will be angle QOP and how much will be angle ROP? Again same, angle bisector. So each angle will be angle O by 2, angle O is 100, 100 by 2, which it will become 50 degree. So this is what we can get, very important note, useful for calculating the sum. Now let us see the worked example based on theorem 4.2. See what is the first example given. Prove that in two concentric circles, the chord of longer circle touches the smaller circle, is bisected at the point of contact. So you can see I have drawn the circle. C1 is the larger circle, C2 is the smaller circle, and they are having the same center O. Before I started theorem 4.2, I explained you the meaning of congruent circles and concentric circles. What are concentric circles? Two circles having same center, center is same, and the radius are different, and they are one inside the other. So C1 is the larger circle, C2 is the smaller circle. And what it says, the chord of the larger circle, AB is the chord of the larger circle, that is C1, and it touches, you can see AB is touching the smaller circle C2. So we have to prove that, what you have to prove? That AP is equal to PB. That means it bisects at the point of contact. So let us state that the point of contact is P. So what is the point of contact? The point of contact is P. So what you have to prove, that AP is equal to PB. So for this we have to write down given. What is given for this? O is the center of the two concentric circles C1 and C2. So what I have to write down given? O is the center of the two concentric circles C1 and C2. AB is the chord for circle C1 and AB touches the smaller circle C2. So given. So what is given? For us, O is the center of circle C1 and C2. So what is given? O is the center of circle C1 and C2. AB is the chord for circle C1 and touches circle C2 at P. That is only what given to us. Okay, so came to know. So what is the given? O is the center of circle C1 and C2. AB is the chord for circle C1 and touches circle C2 at P. What we have to prove? So what we have to prove? We have to prove that AP is equal to PB. For this we need to do construction. What is the construction? The construction says that we have to join OP, very important. So I have joined OP. So what happens now? The proof, let us see. So construction, what you have to write down construction? Join OP. Okay. So when you join OP, now what has become? OP is the radius of circle C2 and AB is touching at P, means AB became a tangent for circle C2. So join OP, that is the construction. So now we will start proof. OP is the radius of circle C2 and AB is the tangent of circle C2 at point of contact P. Therefore, OP perpendicular to AB and it bisects AB because AB is a chord for circle C1. So now what happened? Let us see. OP is the radius of circle C2 and AB is the tangent of circle C2 at point of contact P. Therefore, OP became perpendicular to AB and it bisects AB because AB is a chord for circle C1. So, we know that theorem 4.1. What does theorem 4.1 say? The radius, that is, what is the, when I was explaining you the chord, what I explained you, that the radius drawn to a chord bisects the chord. So, therefore, the radius OP drawn to chord AB bisects it. Therefore, AP is equal to PB. This is what we want there. So, once again, I am explaining you. So, what is given to you? O is the center of the circle for C1 and C2. AB is the chord for circle C1 and touches circle C2 at P. To prove AP is equal to PB, construction, join OP. OP is the radius of circle C2 and AB is the tangent of circle C2 at point of contact P. Therefore, OP became perpendicular to AB. That is your 4.2. Tangent and radius are perpendicular to each other. And it bisects AB because AB is a chord for circle C1. The radius OP drawn to chord AB bisects it. Therefore, AP is equal to PB. So, this is how you prove that AP is equal to PB. This is your example 1. This is second worked example. What is given in second worked example? I will read the worked example. Two tangents TP and TQ are drawn to a circle with center O from an external point T. Prove that angle PTQ is equal to angle 2OPQ. So, see in the diagram. What is given? O is the center of the circle. PT and QT are the two tangents from external point T. And OP is the radius. And what we have to prove? We have to prove that angle PTQ is equal to twice angle OPQ. So, what you will write down the given? O is the center of the circle. O is the center of the circle. PT and QT are the tangents from external point T with P and Q as point of contact respectively. So, O is the center of the circle, PT and QT are the tangents from external point T with P and Q as point of contact respectively. Then what is OP is joint which is the radius. So this is given to you. Now what we have to do? We have to prove. What we have to prove? Here only it is given. Angle PTQ is equal to twice angle OPQ. So angle PTQ is equal to twice angle OPQ. Now we will see proof. What is proof? Let us see. Now you can see that PT and QT are the two tangents. Theorem 4.2, what does it tell us? That the tangents drawn from external point are equal, means TP is equal to TQ. So TP is equal to TQ. Reason: tangents drawn from external point are equal. This is the reason. So if TP became equal to TQ, means the triangle TPQ became an isosceles triangle. A triangle having two sides equal are called as isosceles triangle. So therefore triangle TPQ is an isosceles triangle. If TPQ became an isosceles triangle, means what happens? The angle TPQ and angle TQP became equal. Angle TPQ is equal to angle TQP. Okay. Now in a triangle I told you the sum of all the three angles are 180 degree. Means angle TPQ plus angle PQT plus angle PTQ is equal to 180 degree. If these two angles became equal, means how much those angles will be? So what it will happen? It will become? It will become what it will become? 180 minus angle PTQ by 2. Means from 180 if you subtract angle PTQ and divide it by 2, you will get the remaining two angles, because these two angles are equal. So I will write it down is equal to 180 minus angle PTQ whole divided by 2. This I can take it as 180 degree by 2 minus angle PTQ by 2. So 2 ones are 2 90s are. So I got it as 90 degree minus angle PTQ by 2. That is what I got, angle TPQ and TQP. Now you see this angle OPT. What is angle OPT made up of? Angle OPT is made up of angle OPQ plus angle QPT or plus angle TPQ. Okay, why? Because you can see here, forget this line. See, this angle is made up of two, what you call it as angles, OPQ and TPQ. So I can show that angle OPT is equal to angle OPQ plus angle OPQ plus angle TPQ. Now how much is angle OPT? OP is the radius and PT is a tangent. So theorem 4.1. So how much is angle OPT? Angle OPT is how much? 90 degree. So 90 degree is equal to angle OPQ plus angle TPQ. Why? Because OP is radius and TP is tangent. So using the theorem, you got it. Okay. Now what shall I do? What will be TPQ is equal to? So what will be angle OPQ is equal to? So angle OPQ is equal to 90 degree minus angle TPQ. So what you got? 90. So now here I got 90 degrees equal to angle OPQ plus angle TPQ. Now here angle TPQ value is how much is angle TPQ value? 90 degree minus angle PTQ. So I'll find out what is angle OPQ. So angle OPQ is equal to 90 degree minus angle TPQ. So I will substitute the value of TPQ over here. So what shall I get if I substitute? Angle OPQ is equal to 90 degree minus, in the bracket, 90 degree minus angle PTQ whole divided by 2. Now I will remove from the bracket. Angle OPQ is equal to 90 degree minus into plus is minus, 90 degree minus into minus is plus angle PTQ by 2. 90 and 90 cancels. So what I got in the last, angle OPQ is equal to angle PTQ divided by 2. Nothing is there, means 1. So I will do cross multiplication because I wanted to find out angle PTQ. So what I got? Therefore, so in the last what I got it? So therefore angle PTQ is equal to twice angle OPQ. This is the result of your example number 2. So came to know how to do it. So let us see once again. What is given over here? O is the center of the circle. TP and TQ are the two tangents from external point T with P and Q as the point of contact respectively. Then OP is the radius which is joined. Now we have to prove angle PTQ is equal to twice angle OPQ. Now we know that TP is equal to TQ because tangents drawn from external point are equal. That is a theorem number 4.2. So what can we show? That triangle TPQ is an isosceles triangle. So if it is an isosceles triangle, then the angle opposite to these two sides should also become equal. So angle TPQ is equal to angle QP is equal to 180 degree minus angle PTQ by 2. So what we got it as? 180 by 2, 90 minus angle PTQ by 2 is equal to 90 minus angle PTQ by 2. What is angle OPTC over here? Angle OPT is made by angle OPQ plus angle TPQ. So I want to find out what is OPT. OPT is 90 degree. Why? Because OP is radius and TP is tangent. 4.1 theorem. Tangent and radius are perpendicular to each other. So I want to find out what is the OPQ value. So I took OPQ this side and TPQ I brought on the left hand side. So what I got? Angle OPQ is equal to 90 degree minus angle TPQ. Now I will substitute the value of TPQ. What is the value of TPQ? 90 degree will remain same minus 90 degree minus angle PTQ by 2. I will remove from the bracket. Minus into plus is minus. So 90 degree will remain as it is. Minus 90 degree. Minus into minus is plus. Plus angle PTQ by 2. Plus 90 and minus 90, what happens? Cancels. So I got it. Angle OPQ is equal to angle PTQ by 2. Nothing is there, means 1. If I do cross multiplication, what shall I get it as? 1 into angle PTQ is angle PTQ. 2 angle OPQ. 2 angle OPQ. That is only what you have to prove. So you have proved your problem number 2. Now let us see sum number 3. PQ is a chord of length 8 cm of a circle radius 5 cm. The tangents at P and Q intersect at a point T. Find length of TP. So let us see in the diagram that O is the center of the circle. TP and TQ are the tangents. And PQ is the chord. The measurement of PQ is given as 8 centimeter and OP is the radius whose measurement is given as 5 centimeter. So to calculate the length of PT, we have to do construction. So what is the construction we are going to do? We have to join. We have to join OT. So what we have to do? Join OT. Okay. Now you are seeing that if we join OT, it is intersecting the chord PQ and the point of intersection is R. So join OT such that it intersects chord PQ at R. So you can see over here OT is joined, which is intersecting chord PQ at R. Now OT is an angle bisector of what you call it as angle PTQ. So OT bisects angle OTP. That is your figure number 4.2 in the note we saw. And here what we are seeing that PQ is a chord and OR is drawn to PQ, means OR bisects chord PQ. So OR bisects chord PQ. So if OR bisects chord PQ, means what will happen? PR will become equal to RQ. So therefore PR is equal to RQ. And how much it will become? It will become half of PQ. So it will be equal to PQ by 2 is equal to 8 by 2. 2 1s are 2 4s are. So is equal to how much you will get? 4 centimeter. So you got it. OR is equal to 4 centimeter. Now we have to find out, okay, what is the length of PR? We know that PRO is a right angle triangle because OR when drawn to PQ is perpendicular to what we call it as PQ. So OR perpendicular to PQ. Therefore, in triangle ORP, angle ORP is equal to 90 degree. Therefore, OR square is equal to OP square minus PR square is equal to. OP is how much you have got. OP is given to you. It is how much? 5 square minus PR. Just now we found out how much it is. 4 square. So that will be equal to 25 minus 16. It will be equal to 9. So you got OR square. So OR is equal to square root of 9. That is equal to 3 centimeter. So you got the measurement as 3 centimeter. Now we have to find out TP. So just now only I told you to find out TP. We are going to take similar triangles help. To take similar triangles help, we have to take which two triangles? PRT and PRO. We have to prove any two angles are equal, and there are two proofs for this. So first I am going to take proof 1 using similarity triangle, and second proof is you have to use Pythagoras Theorem. So that two proofs we will see. First I am going to teach you proof number 1. So, which are the two triangles? PRT and PRO. One angle we got it, that is angle PRO is equal to angle PRT is equal to 90 degree because OR is perpendicular. So, what happened? It became 90 degree. But you have to find out which is the second angle. So, how to find out the second angle in these two triangles? Now, look over here. OPT is given. In this diagram, you can see OPT is made up of two angles. One is angle OPR and another is angle RPT. Means what? Angle OPT is sum of angle OPR plus angle RPT. So that we are going to take over here. And you can see that angle OPR is 90 degree. How ma'am it became 90 degree? OP is a radius and PT is a tangent. So tangent and radius are perpendicular to each other. So angle OPT will be taken as how much? 90 degree. So we are going to write it down. Angle OPT is equal to angle OPR plus angle RPT. Angle OPR plus angle RPT. Now just now only I told you angle OPT is 90 degree. So 90 degree is equal to angle OPR plus angle RPT. What is the reason? OR is, what is OR? What is the reason over here? What we are taking over here? Angle OPR plus angle RPT is equal to how much it is? 90 degree. So what is the reason over here? OP, can you see? It is a radius. OP is radius. And second one, TP is tangent. So radius and tangent are perpendicular to each other. So it became as equal to 90 degree. So this you take it as equation number 1. So what you got equation number 1? 90 degree, that's angle OPR plus angle RPT is equal to 90 degree. Now let us go to the next triangle, that is angle PRT. Now you can see that in triangle PRT, angle PRT is 90 degree because angle ORP plus angle PRT, it is a linear pair. If this is 90 degree, then angle PRT will become also 90 degree. So we are going to take in triangle PRT, angle PRT plus angle TPR plus angle, okay, plus angle RTP is equal to how much? Sum of all the three angles is how much? 90 degree. So that we will show it. So what we will show? Angle PRT plus RTP plus angle RTP plus angle TPR plus angle TPR is equal to 180 degree. Just now only I told you angle PRT is 90 degree. So I will substitute the value of angle PRT. So what we got it as 90 degree plus angle RTP plus angle TPR is equal to 180 degree. This 90 degree I will take to the other side. So what you will get? Angle RTP plus angle TPR is equal to 180 degree minus 90 degree is equal to 90 degree. This is your equation number 2. Now let us compare 1 and 2. What is 1 given? 90 degree is equal to angle OPR plus angle RPT. Here also angle RTP plus angle TPR is equal to 90 degree. So comparing 1 and 2, that is axioms. Axiom 1. What does axiom 1 say? Things which are equal to same thing are equal to one another. So we are going to compare equation 1 and equation 2. So what you will get it as? Angle OPR plus angle RPT is equal to angle RTP plus angle TPR. Now pay attention over here. See, RPT, TPR, angle is same. Equal sign is written and same angles are written on both the sides. The angle gets cancelled. So therefore, you got it as angle OPR is equal to angle RTP. Let this be as equation number 3. Now you will take a similar triangle. Which triangle? Angle PRT and angle PRO. So in triangle PRT and triangle PRO, two angles you are going to have to prove that they are equal. One is angle PRO is equal to, so what we will get? Angle PRO is equal to angle PRT is equal to 90 degree. Second is over here, angle OPR is equal to angle RTP is equal, and that is through equation number 3. That is equation number 3a. So what happened? Therefore, triangle PRT, what it is? PRT is similar to triangle. Which triangle? PRO. Now we have to see which vertices are corresponding to which vertices. So you can see R and R, they are corresponding to each other. So R corresponds to R. So in PRT, R corresponds to R. Then in PRT, the T corresponds to P. So T corresponds to P. So what is left out here? P is left out, and here O is left out. So P corresponds to O. Now we have to find out what is the value of TP. So what will we take? TP is the side of triangle PRT. So we will take ratio TP. So if you take TP, means what will come? PO is equal to. Why we are taking? Means we have the value of OP is there, OR is there, and PR is there. That will help us to find out the value of TP. So then what will happen next? PR value is there. Means so in RTP triangle, PR means this will come RP. RP. If you take RP over here, you have to take RO. Now just we have to substitute the value. So TP will remain as it is divided by OP. What is OP value? 5 is equal to RP. What is RP value? We have taken RP or PR is equal to 4. So 4 centimeter. By OR or RO, how much it is? 3. So we have to do cross multiplication. That means 3 TP is equal to 4 into 5. What is 4 into 5? 20. So what you will get? 3 TP is equal to 20. Therefore TP is equal to 20 by 3. That it be like that only. So how much you got? TP is equal to 20 by 3. That is 20 by 3 centimeters is the measurement of TP. If you want, you can convert it into decimal. So if you want to convert it into decimal, means what? 20 you have to divide by 3. So 3 6 are 18. Again 2 0. So what will happen? It is a recurring. So you will get 6.6. So you can take it as also 6.6 centimeters, or you can write it down as just 20 by 3. So 6.6 centimeter. This is the proof 1 to show the value of TP by using similar triangles. Proof 2, I told you that I will explain today. But according to me, first you learn what is proof 1 with the help of the similarity triangle, because 2 proofs if you will learn, it will confuse you. So proof 2 tomorrow I will give for the same sum. So today you learn proof 1. It is on similarity triangle. So go through that, and then tomorrow I will give you proof 2, which is based on Pythagoras Theorem. So I am going to stop the video over here. Bye children, and thank you children.